Hey there. Welcome to the presentation, everyone. Today, we in Group 9 are here to present our development plan for the Bookkeeper application. My name is Jonathan Wacholtz, and the rest of the team here will be walking you through our plan for the beginning of the Bookkeeper app. The Bookkeeper app is meant to be a way that someone can organize their book files in one place and view them in a readable format. Whether it be managing your textbook collection or keeping track of text documents, the Bookkeeper can be used. One of the future features that can set this project apart from the rest will be the ability to translate any of the ebooks in your database into audio. This can essentially turn any ebook into an audiobook. Here, we will go over our development plan for the Bookkeeper app, including cost and time estimates, the project requirements, as well as the use cases that should be met by the end of the project's first development cycle.
So our group decided to use the functional point algorithmic model to estimate effort in development. We chose this as opposed to application composition because that model is better suited for applications that are heavily relying on pre-existing databases and applications. Ours will not do this. It'll have mostly internal processing in terms of downloading a book, reading a book, deleting a book, and searching for a book. And the majority of our interfaces are graphical user pages that interact with each other. So we do not need the complexity that the application composition model supports. The most important thing when developing our project and talking about the effort is paying attention to ease of access and user enjoyment. A survey by Tech.co revealed that 79% of users will not try an app more than twice if they're dissatisfied, and 84% of users rely on other user ratings to decide if they'll download. So user satisfaction is paramount for our app and will be the most important thing that we consider when it comes to effort.
We want to develop for multiple platforms, so we need multiple test devices to cover Android, iOS, macOS, and Windows development. We chose the iPhone SE, retailing for $399 because it has all the necessary features, supports the latest iOS version, and is the most cost-effective option. For Android testing, we chose the $349 Pixel 4a for the same reasons, and because we need to work with a pure version of Android so we don't run into unexpected problems arising from a manufacturer or customized version of Android, and to maintain the greatest compatibility with all target devices. For general development, macOS and Windows testing, we chose MacBook Airs, retailing at $929 to accommodate remote work, portability, and to cut costs by developing on a single device that can run macOS and Windows. Finally, as a cloud backup solution for development assets, we chose Google One because of competitive pricing, reliability, and ease of use. For a team of 5, the total cost for 5 of each device and 5 Google One subscriptions comes out to $8,444.94.
Before doing the functional point analysis, I'd like to consider some intangible factors that may not be outlined by the method. Those would be the organization of the books, meaning what kind of databases do we use, how do we do that, and are we consistent with where we're getting our books from. Another thing is group delegation and expertise. We have a lot of members that have similar skill sets, so we need to make sure that we put people on the right tasks so that we're not wasting time and effort if they could be doing something they're better suited for. And the last thing is future development support. There's a lot of ways we can take this application. We need to make sure that we make code that is allowing for this. So here are the 5 categories of the functional point analysis. We determined that user inputs, user outputs, user queries would all be simple complexity, mainly because they deal with things within the system and they're simply interfacing with each other. And user queries will be something simple like string pattern matching. The other 2 categories, data files and external interfaces, we determined to be a little bit more complex and just said that they would be average. And the reason being is that they're interfacing with online book databases, which we'll need to organize, figure out how to interface with them, and decide which ones to keep using. So to get the function points, we first calculated the gross function points, which we ended up with 47 after using this table. We multiply the amount of categories by the complexity weight and add them all up. For the PCA, or processing complexity adjustment, we answered 14 different questions on a scale of 0 to 5, 0 being not important to our project and 5 being very important. And then we multiplied by 0.01, and after doing that, we got 0.86 as our PCA. And then finally, to get the FP or function points, we multiply the gross function points by the PCA factor, and we get 40.42 function points. Lastly, we'll use the functional points that we just calculated to estimate how long the project will take and how much effort it will take. Effort will be based on function points divided by the productivity of team per week and how many team members we have. We'll have 5 different team members, and we have 40.42 function points to work with. We estimate we can do about 15 function points per week as a team, and I used a reference to the slides for chapter 23, which said that a developer team of 5 developers could do about 60 functional points per week. Given that we likely have a fourth of the experience programming as they do, we can do about a fourth of the work. So the effort, E, would be 40.42 divided by 15 equals 2.695, and we round up and we get about 3 person weeks for this project. We have 5 people on our team, so the duration will be 3 person weeks divided by 5 people, rounds out to about 1 week for this project to be done. However, we will need about 2 weeks to test the product before we release it. So in total, our team estimates 3 total weeks before we can release Bookkeeper.
This is an estimated project timeline. This software application will be developed using Agile methodology, so the tasks are broken up into week-long sprints. This application is not very complex, so in a team of 5, it should not take too long to complete. This is consistent with the function point estimation, which resulted in a low number. The 5 people will be divided into 2 dev teams of 2, while 1 person handles testing. Testing does not start until November 12th, so until then, that person will work on development. This will allow features to be developed concurrently. Development itself takes a week or 2, but testing and deployment make the application timeline longer.
During the planning process for our project, we zeroed in on these key functional requirements. The user must be able to load books from their system and into their Bookkeeper database, delete books from their database as long as that specific book is already a member of the database, add categories to books present in their virtual library in Bookkeeper, delete categories from books present in their virtual library in Bookkeeper, and search within the contents of their books using text queries.
Aesthetically, we want to create a minimalist, uncluttered UI, making the book the focus. With regards to performance, no intensive computation is involved. In-book operations such as scrolling and page-turning animations should be elegant and short, with no noticeable lag. Loading and deleting books in the library should be similarly instantaneous, with large operations over multiple books taking only a few seconds. Since our core application has no connectivity requirement, it should be stable and highly available. The application should use minimal system resources since it handles relatively small files. In the event of a crash, the user should be gracefully notified, the user's data should be backed up, and the application should be restarted, all within 5 seconds.
Our goal for the beginning development of this project is to get the most basic uses for a book reader done. First, the user must be able to add books from their system into the Bookkeeper's database, as well as remove them. From here, they'll be able to open up one of their books and read it in a viewable format. More viewing options are going to be added later, but for now it'll just be a basic window display of the text contents of the book. We also want to get another feature of being able to create custom lists from the book so that you can categorize them further. This would be something similar to creating tags or genres for your books. Once we have all that, we want to be able to search for a book by its title as well as other categories and tags.
This is the sequence diagram for View Book. In order to view a book, the user clicks on the category and the list of books in that category is displayed from the database. The user then clicks on the book they would like to view. The application gets the content of the book from the database and displays it to the user.
For our testing, we made an ebook class in Java and added the basic parameters that are needed for an ebook. Assuming that the book's file directory is valid, the function openBook is being tested to see if it will accurately return the text contents when given a starting file position and an amount to read. This structure is what will be used later to open pages of a book, since to get a page, you just take the page's starting position in the file plus the amount of characters you want on that page. OpenBook is going to be tested using Java's JUnit testing class, specifically its assert equals method, to see if it can successfully read the first 25 characters from an input file.
The content of the input text file used in our unit testing plan is the quick brown fox jumps over the lazy dog, wherein the first 25 characters, including white spaces, are the quick brown fox jumps. The JUnit test will be walking through two cases, successful case and failure case. In successful case, we observe if the testing output is the quick brown fox jumps, which is exactly identical to the first 25 characters found in the input text file. In failure case, we observe if the testing output is the quick brown fox, which is only 19 characters of the input text file. The JUnit test ensures that our book reading unit's behavior is exactly as we wanted it to do. Class diagram. Bookkeeper will need two classes at a management level to handle the book and category, one class at database level, and two classes at object level, book and category. The instance of the book management is built on top of the book database to query the book database content and reference its behaviors. A book object indicates the book content and its details, including author, title, total page count, and category. Book objects are also capable for actions that are directly reading, getting, and modifying the book's content and details. The category management managed object implemented from the category class. Category objects reference categories of the books. Category objects also provide actions to get the list of the books belong to this category, as well as get and set the category title.
For the architectural design, after a thorough analysis of alternatives, our group decided that the model view controller pattern would best fit our bookkeeper application. MVC is commonly used for web applications, can have multiple different presentation views, and it has separate components. We felt that the extensibility and flexibility offered by the MVC design's division of features into components would be particularly beneficial for an application which could easily be expanded to have internet-based features, such as buying books from an online bookstore or retrieving books in an online drive. The model component contains the book database, and the database contains information on the annotations the user has made, where they have left off in each book, and of course, their library of books. The model also contains the logic for the automated conversion of text to audio for users who would rather listen to their books. This is the feature of our bookshelf app that distinguishes it from those currently available. The view component contains book management, category management, and page views. Multiple presentation views are needed to scroll through books and show the user their library. The controller component handles requests and returns responses. Organizing the system into three parts, model view and controller, allows data to be changed or updated without updating the other two components.
This is one example design of the user interface for a bookkeeper where the user can view the list of books.
Through our research, we decided that the most valuable niches our product could fill were in accessibility and ease of use. We eliminated an account requirement because our application does not have high security requirements and is intended to be used on single-user devices. We added a feature to back up the user's books and bookmarks to protect against data loss from crashing, and because user convenience was a high priority. We pushed online features such as online book buying and cross-device synchronization into the future because while valuable, we felt it was more necessary to focus on fine-tuning core functionality in the first version. We hope you enjoyed seeing what we have in store with Bookkeeper. If you have further inquiries, our team will happily answer your emailed questions. Thank you for attending.